Okay, in this class I'm going to continue our work on Newton's laws and angles on rough planes. And the question here says, what value of mu would prevent the block from slipping? We've given a mass of 10 root 2. We're on a plane that's inclined at 45 degrees. It's rough. We're trying to find what value of mu would prevent the block from slipping. So just like before, I'm going to put in my weight vector. Always a good one to start with. Acting towards the center of the earth. My normal reaction perpendicular to the plane of contact. We've got friction acting in some direction back here. Those are all the forces. The force that needs resolving is the force that is neither parallel nor perpendicular to the plane, which in this case is the weight. So I'm going to resolve it to be parallel and perpendicular to the plane. Okay, so that is my weight vector. Filling in here, my weight vector is always equal to the mass times the acceleration due to gravity, so 10g times root 2. We know that has to be 45 degrees from geometry. If that's 45 degrees, that has to be 45 degrees. Working out special triangle, that's a 45, 45, 90. The sides will be in the ratio 1 is to 1 is to root 2, so this must be 10g. This must be 10g. That's in that direction, that's in that direction. What about the normal reaction? Well, there's no acceleration into the plane or away from the plane, so perpendicular to the plane, the forces up away from the plane must equal to the forces down, because there is a net force of 0 there, which means my normal reaction has to equal to 10g. So that's 10g. My friction, well, before we think about friction, the maximum possible value for friction. So friction is this force here. The maximum will be mu times the normal reaction. Mu is the coefficient of friction. It depends, I suppose, really on what materials the block and the slope are made from. In order to prevent motion from happening, friction would have to be able to match the force that's acting in that direction, and the force on the block acting parallel to the plane is 10g. So in order to prevent slippage here, friction would have to be able to match that, which would mean there's no net force. Okay, so in order to prevent that, the maximum friction, friction would have to be 10g. So how do we make that friction force 10g? Well, it's mu times the normal reaction, which is 10g, and the number I could assign to mu to make this equal to 10g, which will be would be 1. So the friction up here, the maximum friction of 10g will be reached if mu is equal to 1, which is our maximum value for the coefficient of friction. So if mu is equal to 1, then my maximum friction is 10g. That means I'm using all of my 10g here. My force in the negative direction parallel to the plane will be 10g. My force in the positive direction will be 10g. That means my acceleration will be 0 because the net force will be 0. So a block placed on the plane will not slip. So if mu is equal to 1. I want to investigate what happens here. I've got a coefficient of friction of 2 root 3 over 9. This is a 30-degree angle in this case. I'm going to fill in my vectors here. I've got a force, my weight force down. My normal reaction perpendicular to the plane. I'm going to have friction acting opposite to the intended motion of the object. Remember, the weight is always equal to the mass times the acceleration due to gravity. Here we have the normal reaction. Here we have friction. Remember, the maximum possible value for that friction is going to be mu times r. Okay. Resolving the one vector that is neither parallel nor perpendicular to the plane, that's the weight vector. we need to be able to see quickly that that is 30. You need to investigate your geometry. Went over it the last day on the live lesson, so practice it, make sure you can figure out where that 30 comes from. This is a 30, 60, 90 triangle. This side here will be 10g sine 30, this will be 10g cosine 30. However, you know, in a 30, 60, 90 triangle, the side opposite 30 is always half the hypotenuse. The side opposite 60 is always the side opposite 30 times root 3. If I investigate the perpendicular forces, well, perpendicular to the plane, the object is never going to accelerate into the plane or away from the planes, which means if there's no acceleration in that direction, there's no net force, which means the force up away from the plane, perpendicular, must be equal to the force perpendicular down into the plane. So we get that the normal reaction, the force up away from the plane, has to equal to the force downwards into the plane, which is this 5g root 3. So the normal reaction here is 5g root 3. The coefficient of friction is 2 root 3 over 9. So my maximum value here for friction, the most the friction can reach, will be 2 root 3 over 9 multiplied by the normal reaction, which we said was 5g root 3. And that's just 5g root 3 over 1. So root 3 by root 3 is 3. 5 2s are 10. So I'm going to get 3 times 10, or 30g over 9. So coefficient of friction here, sorry, not the coefficient of friction, my friction force is going to be 30g over 9. Okay, that'll reduce, of course. 3 is common factor, top and bottom. That's 10g over 3. Okay, 10g over 3, which is, you know, if you think of it as a decimal, that's 3.3 recurring times g. And that's going to be opposing this force. Notice it does that's the most it can reach. If it could reach 5g, it would, but it can't. It can only reach this, so it can reach this 10g over 3. That's the most it can get up to. So if I want to look at my forces parallel to the plane, F net equals ma. The net force here is going to be 5g. And again, assigning this to be positive in that direction. So 5g is my positive force minus this force, 10g root 3. 10g, sorry, over 3. And that's equal to the mass, which is 10 times the acceleration. So I can work out the acceleration of the object in this case. 5g is 15g over 3, so 15 over g over 3 minus 10g over 3 would be 5g over 3. That's equal to 10a. Dividing on both sides by 10, I get 5g over 30, or 1g over 6 meters per second squared. So this object is going to accelerate downwards at a rate of 1/6 of g, little g, where g is approximately 9.8. Okay. Let's have a look at another example. 30 degrees. You know, my forces are almost exactly the same. We have my weight force down. Always going to start with that one. My normal reaction perpendicular to the plane. I've got my friction. I'm just going to put in the name for each of those, or F, and my weight here, W. But my weight I know is always 10 times little g. I'm just going to put that as 10g. I'm going to resolve the force that is neither parallel nor perpendicular to the plane of motion, which is this one, 10g. Working out, that has to be 30. We worked out previously that has to be 5g, that has to be 5g root 3. So from that I can work out my normal reaction, because perpendicular to the plane, you know, there's going to be no acceleration down into the plane or away from the plane. So the force up perpendicularly away will be equal to the force down perpendicularly into the plane. So the normal reaction has to be equal to this 5g root 3. That has to be the case. Think about friction. Well, the maximum value my friction can be is equal to mu, which is root 3 over 2, times r, which will be 5g root 3. Multiplying out root 3 by root 3, well, remember that's over 1. It's going to be 3 times 5g, which is 15g over 2. Now, that's my maximum force. So this is interesting. That's my maximum frictional force, because 15g over 2 is 7.5g. So, what's going to happen here? Is my friction force going to get up to 7.5g? And we're going to just think about the forces parallel to the plane. Well, pushing this block down along the plane is this 5g force. Friction, in order to prevent motion, remember friction can't create motion, it can prevent motion. So in order to prevent motion, friction has to oppose this. It can get up to 7.5g if it needs to. In this case, it won't, because if it got up to 7.5g force, well, that would create a movement up the hill, which wouldn't make any sense whatsoever. So in fact, friction here is going to just get up to 5g, which it can do because it can get up to 7.5g, and then that's it. That's all it's going to do. And it's going to stay there. And parallel to the plane then, where we 5g pushing down along here, I've got a 5g force pushing down parallel to the plane. That's just pushing this thing down the plane. I've got a 5g force. My friction force is 5g, pushing up away from it. So my net force is 0, which means my acceleration is 0, because net force is equal to mass times acceleration. So interesting. Be careful. Don't just go and plug in 7.5g in here into your kind of diagram. It wouldn't make sense. It can get up to 7.5g if it needs to, but in this case, it doesn't need to. It only needs to get up to 5g, and that's all it will do. It only goes as far as it needs. Okay, so a few examples in there on friction. Keep practicing those sections. 5b in your textbook. I'll be moving on to connected particles the next day. So practice, practice, practice.